Welcome back, Mrs. D here again. We kind of ran out of time for the windshield wiper problem, and so here we are with a brand new video clip. The windshield wiper on a car, and I've drawn it here. This is what it does. It goes, and if you haven't noticed, it doesn't quite cover the whole windshield, but it does kind of clean an area like this shape. And there are two parts to the wiper blade, and this is usually the part that people are confused about. The entire wiper is 20 inches long. That to me goes from where it starts on the car, where it's attached, to the very end. And then the blade, the actual part that does the washing, this is the blade, and that blade is 16 inches. So although my drawing doesn't do it justice with scale, that leaves about 4 inches here between where it's attached and where it actually starts wiping. Now this problem is almost like an arc length type problem, except if it were about arc length, we would be calculating this length out here. And no, that's not what we're trying to do. Remember, arc length, though, is based on the entire circle's circumference, and then a portion of that, some fraction of it. So we can do the same idea here. This really to me is about area then, the entire area, and then a portion of it. So the portion of it is actually the easiest part of this problem. It's 110 out of, I should just say 110 out of 360. And that's in degrees, folks. We could call that 1136 if you prefer. This is not a circle's area, however, it's like a donut's area. So this problem should take you back to geometry days. If you found the area of that donut and then took 1136 of it, you should get the area that is actually wiped. I'm showing some exact numbers here. Pi times 20 squared, take away pi times 4 squared, and that will give me 1,206.37. That would be square inches for the donut, but remember we have a fraction of that. I will allow you to finish that and make sure you have less than 1,206.37 square inches of area wiped clean by this wiper. Our next frequently asked question is kind of phrased in a funny way. You can find this problem in the multiple choice section. I believe it's number 12. The phrasing here is what's kind of strange to people. But actually, if you think about what we're asked to do here and what we're given, this is a ratio. It's a negative ratio. And usually there is an angle that has that ratio. Actually, there's many. Negative sign ratios could be coming from this quadrant or this quadrant, but no others. And we want a negative angle, but not too negative. So that's why they say the greatest negative angle. I don't know, the phrasing's a little bit funky to me as well. But I feel like what we know about inverse sine, this angle is probably the one that we're talking about based on our range restrictions. So, based on my lovely diagram, I think the only two choices, well, I guess, yeah, two choices that would even make sense. Negative 36 degrees, 51 minutes, and negative 48 degrees, 42 minutes. So we'll have to narrow it down from here, and to do that I'm going to use my calculator, because calculators know all of these ratios by heart, even the ones that aren't so special. So I'm actually going to use an inverse sine function here to determine the angle that has this sine ratio, because it's not one that I'm too familiar with. And when I push enter there, paying attention to my mode, I'm getting negative 48.7 degrees. Remember that decimal is a fraction of a degree, 0.7 degrees. We could convert that into minutes by knowing that there are 60 minutes in every 1 degree. Fact, used as a scalar multiple, and that, ladies and gentlemen, is how we get this 42 minutes. So there's our answer. It's a negative angle. It's the greatest one we can get using the inverse sine function. It would never go past negative 90, and there you have it. Last two commonly asked questions. This first one is cotangent of 197 degrees to 4 decimal places, and a person says, huh? I can't do that on my calculator. Well, the thing you need to understand about cotangent is that this is a reciprocal ratio. Yes, it's adjacent over opposite, but more importantly, I like to connect it to tangent. So if you know the tangent ratio, it's the reciprocal of that, and this would be a good time to say, hey calculator, what's the tangent of 197 degrees? Whenever you get that number, again, pay attention to your mode. The cotangent of 197 degrees is just the reciprocal of that number. You could invert that fraction if it's in fraction form, but chances are it's going to be a decimal type number, in which case I would do the reciprocal of that 1 over that number, and you'll get a nice number. It's actually a larger number than 1. The final problem I just want to point out, some vocabulary here: isosceles triangle, base of 12, vertex. Oh my gosh, this is just full of juicy vocabulary. We want the equal sides. So if you didn't know it, isosceles triangles have 2 equal sides. The vertex angle of this triangle, I guess it matters which vertex we're talking about. In an isosceles triangle, the base is the one side that's not the same length, and actually the vertex is across from that base. So this is the vertex point, vertex angle. These are actually called your base angles. They should also be equal to the same measure as one another. But here we go back to the problem. 52 degrees is the vertex angle, and we know the base is 12 meters. So to find the length of the other two sides, this is definitely not a time to use Pythagorean's theorem, because it's not a right triangle yet. However, if I dissect it, cut it, and this really only works with isosceles triangles, that's why that had to be given to us. Over here on the right or left, we have congruent triangles. Little base here of this right triangle is 6, and I've also bisected that angle to be 26 degrees. So if I want to find this unknown measure, seems like a good time to use sine ratio. Sine of 26 degrees would be 6 over x. You can solve that equation using your calculator, of course, and your answer choice that matches here is C. Hope you've enjoyed studying with me. Please come prepared for the test tomorrow. I'm sure you can do it. Do you believe? I do too. Okay, work hard at it and you'll be ready.